Quick question. Are you a firstborn kid? Maybe you're the eldest in your family. Maybe you're a middle child. Maybe you're the youngest. Wherever you fall in that lineup, what if I told you that your spot in the birth order, the order in which you were born, might have quietly shaped how your brain developed? Because here's the thing, study after study keeps pointing to the same finding. Firstborn children, on average, score higher on IQ tests than their younger siblings. Not by a massive gap, but consistently. And it's showing up across different countries, different income levels, different family sizes. So naturally, that raises a few big questions. What even is IQ, and how do we measure it? Who actually has higher IQs, and why? And then the big question, what is it about being born first that seems to give kids a cognitive edge? Is it genetic? Is it how parents raise their kids? Is it something that happens before the kid even takes their first breath? We're going to break all of that down using actual science. And by the end of this video, whether you're a firstborn feeling smug or a younger sibling ready to argue, you're going to understand exactly why this happens. And honestly, the answer is a little surprising. Let's get into it. What even is IQ? All right, before we get into birth order and all that, we need to establish a baseline, because IQ gets thrown around a lot, and most people have a kind of fuzzy idea of what it actually means. IQ stands for intelligence quotient, and the word quotient is key, because originally it was literally a math problem. Early in the 1900s, French psychologist Alfred Binet was asked by the French government to figure out which kids were struggling in school so they could get extra help. He came up with a test that compared a child's mental age to their actual age. If a 10-year-old was performing at the level of a 12-year-old, that kid's IQ would be higher than average. That formula got refined over the decades. The version most of us are familiar with today comes from tests like the Stanford-Binet and the Wechsler scales. And rather than comparing you to some fixed standard, modern IQ tests compare you to the general population your age. The average is set at 100. Most people, about 68% of the population, fall somewhere between 85 and 115. Scores above 130 are considered gifted. Below 70 typically indicates an intellectual disability. But what do IQ tests actually test? Now here's where it gets interesting. Modern IQ tests don't just measure one thing. They measure a range of cognitive abilities that researchers group into two big categories. The first is fluid intelligence. That's your ability to solve new problems, think logically, spot patterns, and work through things you've never seen before. It's your raw processing power, basically. The second is crystallized intelligence. That's the knowledge and skills you've built up over your lifetime. Vocabulary, learned facts, learned reasoning strategies. It grows as you age and learn. A full-scale IQ test, like the Wechsler Adult Intelligence Scale, tests both of these, plus things like working memory, processing speed, and spatial reasoning. The result is one composite number, but it's really a summary of a whole bunch of different mental abilities. But is IQ actually a reliable measure? This is a fair question, and the honest answer is, it's complicated. IQ scores are actually pretty stable over time for most people, and they correlate with a bunch of real-world outcomes like academic performance, career success, and even certain health outcomes. So it has predictive value and arguably a useful research tool. But IQ is not the full picture of human intelligence. It doesn't capture creativity, emotional intelligence, social skills, wisdom, or practical problem-solving in real-life situations. It's a snapshot, not a complete portrait. Some argue IQ can be influenced by education, nutrition, environment, and even test-taking practice. It's not some fixed number carved into your DNA at birth. But for the purposes of research, IQ scores are one of the most consistent and widely used tools we have. And that's exactly why researchers use them to study things like birth order, the reason you clicked on this video. Environment matters more than most people think. Okay, so now that we understand what IQ measures, let's talk about who tends to score higher and why. Because this is where a lot of people have misconceptions. For a long time, there was this temptation to look at IQ differences between groups of people and just chalk it up to genetics. But the research doesn't really support that. What it does support, overwhelmingly, is that the environment plays a massive role. Three factors keep coming up again and again in the research. Number 1, nutrition. There's strong evidence that proper nutrition, especially in early childhood and even during pregnancy, significantly affects cognitive development. Deficiencies in iodine, iron, and other nutrients have been linked to lower IQ scores on a population level. There's the Flynn effect, a well-documented phenomenon where average IQ scores have been rising globally over the past century, is thought to be partly explained by improvements in nutrition and healthcare. Number 2, education and early stimulation. Kids who are read to, talked to, and engaged with intellectually from a very young age develop stronger language, memory, and reasoning skills. The quality and quantity of early learning experiences matter a lot. So where does birth order fit into all of this? Here's where it starts coming together. Because when researchers started looking closely at the data, they noticed something. Within the same family, same parents, same socioeconomic status, same neighborhood, same household, firstborn children were scoring measurably higher on IQ tests than their younger siblings. And this wasn't a one-off finding. It kept replicating across different studies, different countries, different time periods. A disproportionately high number of US presidents, astronauts, and Fortune 500 CEOs are firstborns. Is that just a coincidence? Researchers don't think so. A 2007 study on NASA astronauts found that the vast majority were either firstborns or functioned as firstborns due to large age gaps. And multiple surveys of high-achieving professionals show the same pattern. So the question is, why? What is it about birth order that would affect cognitive development? The Norwegian study. Let's start with the evidence. In 2007, two Norwegian researchers, Petter Christensen and Tor Bjørkedal, analyzed IQ data from over 250,000 Norwegian men who had been tested for military service. And after controlling for all the obvious variables, family size, parental age, education, income, they found a clear, consistent pattern. Firstborns scored, on average, about 3 IQ points higher than secondborns. Secondborns scored about 1 point higher than thirdborns, and so on down the line. 3 points might not sound like a lot, but in research terms, that's a statistically significant difference, and it held up across a massive sample size. This wasn't a fluke. But more interestingly, the researchers also looked at cases where the firstborn had died in childhood, making the secondborn effectively the eldest child in the family. And guess what? In those cases, the secondborn's IQ was closer to firstborn levels than secondborn levels. That was huge, because it clearly says that the IQ advantage wasn't really about biology, it was about social position, about being the oldest kid in the family. So then the question becomes, what is it about that social position that boosts IQ? Theory 1. The resource dilution hypothesis. The first explanation is probably the most intuitive. It's called the resource dilution hypothesis, and the core idea is simple. The more children in a family, the more the parental resources get spread out. Resources here doesn't just mean money, though that's part of it. It means time, attention, one-on-one interaction, engagement. When a firstborn arrives, they get 100% of everything. Every bedtime story, every conversation, every learning experience, every moment of eye contact, it's all for them. When the second child arrives, those resources get divided. When the third arrives, divided again, and so on. The firstborn gets a window of exclusive parental investment during the most critical period of cognitive development, those first few years of life. And that early advantage, the research suggests, compounds over time. Theory 2. The tutoring effect. This one's fascinating. Okay, this is the theory I personally find the most interesting. It's called the confluence model, and it was developed by psychologists Robert Zajonc and Gregory Marcus back in the 1970s. The idea has been refined a lot since then, but the core insight holds up. One of the most powerful ways to reinforce your own understanding of something is to teach it to someone else. When you explain a concept out loud, you have to organize it, simplify it, find the right words for it. That process deepens your own comprehension. Firstborn children naturally end up in the role of teacher to their younger siblings. They explain things. They show how stuff works. They answer questions. And in doing so, they're strengthening their own cognitive skills. Younger siblings receive the benefit of having an older sibling explain things, but they don't get the same reinforcement that comes from being the one doing the explaining. It's a one-way street, cognitively speaking. Research backing this up includes a study by Christensen and Bjørkedal, the same Norwegian researchers, where they looked at tutoring behaviors and found that firstborns who actively tutored younger siblings showed stronger cognitive outcomes than firstborns who didn't. But with all that said, IQ could also be affected even before the baby takes their first breath. Theory 3. The womb environment. Now we're getting into some more recent and more biological territory. This one's a bit more speculative, but there's emerging evidence worth talking about. The idea comes from research in immunology and prenatal development. The basic finding is this: with each successive pregnancy, a mother's immune system can develop antibodies that react to certain fetal proteins. One protein in particular that's been studied is called NLGN4Y. It's expressed in the brains of male fetuses. The concern is that maternal antibodies to this protein might affect fetal brain development in later pregnancies. This research is still developing and is primarily focused on explaining certain neurodevelopmental differences, not necessarily average IQ differences. But it does add a potential biological layer to what's mostly been understood as an environmental phenomenon. The takeaway? The womb environment itself may be slightly different for firstborns versus laterborns, and that might play a small role in cognitive development. Nature versus nurture. What does the evidence say? So is this IQ gap biological or environmental? Based on the weight of evidence, especially that Norwegian study where social position mattered more than biological order, it's mostly environmental. The resource dilution and tutoring effect explanations have the strongest support. The biological angle is interesting, but still being studied. But what about only children? Only children don't consistently outperform firstborns on IQ. They get all the parental resources, yes, but they miss out on the tutoring effect because there are no younger siblings to teach. And does this hold across cultures and income levels? Largely, yes. The birth order effect on IQ has been replicated in the US, Europe, and parts of Asia. It appears across income brackets, though it may be more pronounced in lower income families where resources are more constrained. All right, let's bring it home. Yes, the research shows that firstborns tend to score slightly higher on IQ tests. The effect is real, it's consistent, and it's backed by some seriously solid science. The Norwegian study alone, with its 250,000 plus participants, is hard to argue with. But here's what I really want you to take away from this. The gap is modest, and it is not destiny. 3 IQ points is not the difference between brilliant and average. And IQ itself is only one slice of what makes someone capable, creative, or successful.